All right. Hello, everyone. Today we are working on 9.4 and 9.5, which cover our trigonometry ratios. To cover them, I've put together this handy dandy little flip book for us. Or better, I stole this little flip book from a Teachers Pay Teachers site. So we're going to work through to fill some of this out. Trigonometric ratios are super duper important. They're found everywhere in the real world. So it's absolutely vital that as students, we have a firm foundation in what these things are. We're going to start with our first one, which is our sine ratio. Sine ratio. So we start by writing in our first little blank here, sine A. So it's absolutely vital to remember this A here is an angle. We associate sines with angles. Filling in our blanks here, so our ratios give us little fractional formulas. So our first blank is opposite leg over hypotenuse. That's all there is to it. We take whatever leg's on our opposite side and we put it over the hypotenuse. We've got a couple practice problems over here on the right. For sine of A, the first thing I do is I look and I see what's our opposite side? 12. So 12 goes on the top. And our hypotenuse is 13. So that will stay on the bottom. For sine of B, look at angle B here. Go across the figure, and we get an opposite side of 5. On the bottom stays our 13, opposite over hypotenuse. That's all we do here. Okay. Now we're going to look at some example problems involving finding sides. This column on the left here talks about angles. We're not going to worry about that right now. That side doesn't matter. Looking at question 5, we're going to start by saying, I have an angle. Our angle is 41 degrees. So we'll say that sine of 41. Now we want to set up our side ratio like we have up here. So what we put on the top is our opposite leg, and what we put on the bottom is our hypotenuse. Opposite the 41, we have an x. I'm going to put an x on the top, and our hypotenuse is 17. We want to get x by itself and then plug everything into our calculator. So the way we're going to do that, we're going to multiply both sides by 17. When we do that, we get 17 sine of 41 equals x. This is where we plug into the calculator. When we plug in, I want us to make sure that we have 3 decimal places, not 1, not 2, but 3. Take a second, pause this video, and plug it into your calculators, and then have an answer to compare. Now that you've plugged it in, I got 11.153 after rounding. We use these approximate symbols because we round it. Let's do this again on example 6. The big difference here is we're solving for the hypotenuse this time. We already have our leg. I'm looking here and I notice we've got an angle of 73 degrees. So what we're going to do is we're going to say the sine of 73 equals, our opposite side is 29. And then our hypotenuse is x. So that goes on the bottom. This one's a little different. When we solve this problem, this time to get x by itself, we have to multiply both sides by x. So we get x sine 73 equals 29. Our next step is we divide both sides by sine of 73. We get x equals 29 over sine 73, which means x is approximately 30.325. That's the sine ratio. That's one of three we're going to cover in this video. The next one we're going to look at is cosine. We abbreviate this one cos, C-O-S, cos of A, and we say cos of A is equal to our adjacent leg over the hypotenuse. Now, take a second and guess our cosine ratios on the right here. Pause the video and have answers ready or guesses ready when you come back. Okay. For cosine of A, we want to look at our adjacent leg. That would be 5. We have a hypotenuse of 13. So our fraction is 5 over 13. For angle B, the adjacent leg is 12. So and the hypotenuse stays the same. We get 12 of 13, 12 over 13. Notice again, our denominators stay the same. All right, we're going to work a couple examples now. We're going to set these up, and then I will leave you to finish them on your own. So the first thing we're going to do, let's look at number 11 here. I notice we've got 62. We're going to say the cosine of 62, because it's an angle measure, is equal to our adjacent side of x over our hypotenuse of 7. Pause the video and solve this question, and then come back when you've got an answer ready. Now that you're back, the way we solve this is we multiply both sides by 7. So 7 cosine of 62 equals x. After we plug into our calculator, we get 3.286 is approximately x. We're going to do the same thing on 12. So again, we notice our degree measure, 24. So we say the cosine of 24 equals, now we want our adjacent leg on top. 27 is adjacent. So we say 27 over our hypotenuse of x. Take a couple seconds to solve this on your own and pause the video. Now that you're back, we're going to solve it out. We multiply both sides by x. And that gives us x cosine of 24 equals 27. After we divide both sides by cosine of 24, we get x equals 27 over cosine of 24, which means that x is approximately 29.555. Before we go on, one of the things you could be hit with is they could ask you sine of 30 degrees equals cosine of what? Have no fear, we have a formula. Our formula, and it works the other way too. Sine of A equals cosine of 90 minus A, which means we can also say cosine of A equals sine of 90 minus A. The 90 degrees comes from the fact that we deal with right triangles. Take a second now and apply one of these formulas to our mystery problem here. Okay. So what we can see is sine of 30 equals cosine of 90 minus 30. We get that from our formula. That means sine of 30 is equal to cosine of 60. And we're done. Nice and easy with that. Our last one is the tangent ratio. Tangent is abbreviated T-A-N. We say the tangent of A is equal to the opposite leg over the adjacent leg. Pause the video and take a couple seconds to work on 13 and 14 on your own. Now that you're back, the tangent of A, we take our opposite leg of 12, our adjacent leg of 5, 12 over 5. Tangent of B, we take our opposite leg of 5, our adjacent leg of 12, for 5/12. Notice that these two fractions are reciprocals of each other. Also notice tangent does not use the hypotenuse. That's a no. Let's work a couple examples of this. Looking at number 17 here, we're given 75 for a degree measure. So we say tan of 75 equals our opposite side x over our adjacent side 18. So 18 tan 75 equals x. This means that x is about equal to 67.177. Take a second to set up and solve 18 on your own. Now that you're back, we say tan of 39 equals 49 over x. That means that x tangent 39, after we multiply on both sides, equals 49, and x equals 49 over tangent 39. That means x is approximately 60.510. We've used all of these functions in isolation. One of the tricks you have to do is knowing which one to use on its own. So my hint, if there is no hypotenuse, tangent. Otherwise, you're going to have to choose between sine and cosine. Let's look at our mixed practice on the next page. We're only going to worry about 23 through 26. We'll come back for the rest later. On 23, we have to choose which trig ratio to use. I notice we've got our 38. We've got the opposite side and the adjacent side. There's no hypotenuse length. So we want to do tan of 38, tangent, because there's no hypotenuse, equals 13 over x. We carry out our same process as before, multiplying both sides by x, and then dividing by tan 38. Which means we get a final answer of x is approximately 16.640. Awesome. 24, let's look at that one now. We've got our 14 degrees. Take a second to decide which ratio you want to use. Pause the video while you think. Now that you're back, we see that we want to use tangent because we have both legs but no hypotenuse. So we tangent of 14 equals x over 29 after setting up our fractions. Multiply both sides by 29 and we get 29 tan 14 equals x. If you plug that into your calculator, you should get 7.231. It's approximately x. All right, now that we've got a couple of these under your belt, try 25 and 26 on your own. Pause the video, and when you're ready to start back up, press play. For 25, we want to use the sine ratio because we have an opposite side and a hypotenuse. So we say sine of 51 equals x over 35. That means 35 sine 51 equals x. So 27.200 is approximately x. For 26, we have 47 degrees and we want to use cosine. So we say cosine of 47 equals 7 over x. Again, using our adjacent over hypotenuse. Then, after multiplying both sides by x, we get x cosine of 47 equals 7. And x equals 7 over cosine 47. After we do that in our calculator, we get x is approximately 10.264. Awesome. We've got just a little bit more, so hang in there with me. Our last piece is we're going to look at some word problems. If you flip the page, we've got applications. Our first set are angles of elevation. Angles of elevation are looking up. So that would be an angle of elevation. On 27, Jack is at the zoo looking up at a monkey on top of a pole. If Jack is standing 24 feet from the foot of the pole, and the angle of elevation from Jack to the top of the pole is 23 degrees, find the height of the pole. Let's draw a picture. Got Jack here, pole here, and I have no monkey, so I'm just going to draw a circle. Jack, we know Jack is 24 feet from the base. We also know that the pole sticks out of the ground at a right angle. Let's complete our triangle to see we have a right triangle. And we want the height of the pole as x. The last piece we need to fill in is our angle of elevation. We're going to put that right here. That'll be 23 degrees. Take a second to set up your equation and solve. Now that you've given it a try, we're going to say tangent of 23. We use tangent because we don't have a hypotenuse, is equal to x over 24. That means 24 tan 23 equals x, which means 10.187 feet is approximately x. Take a second to try 28 on your own. Pause the video. And now that you're back, let's try it together. So we've got the angle of elevation from Allison to the top of the statue is 70 degrees. The Statue of Liberty is 305 feet. How far is Allison from its base? We get our picture drawn. Got little Allison, Statue of Liberty. We want this mystery x distance. We know our statue is 305 feet tall, and our angle of elevation is 70 degrees. We can use a tangent expression here. Tangent of 70 equals 305 over x, opposite over adjacent. Multiply both sides by x to get x tan 70 equals 305. And then divide both sides by tangent of 70 to get x equals 305 over tan 70. Which means x is approximately 111.011 feet. Remember to put all of these answers in complete sentences. I'm not doing it here because I don't have space, but make sure that we are doing that. The last example we're going to work today is an angle of depression example. We're only going to do one of these, and the other one is there if you want to practice. The angle of depression, we're working on 31. But first, we should define the angle of depression. Depression in math means that we're looking down. So an angle of depression is going to look something like that. Let's do a problem. The angle of depression from a helicopter to a landing pad is 37 degrees. If the helicopter is 1250 feet from the ground, what is the horizontal distance? Let's get a diagram drawn first. I've got a little helicopter here. Landing pad. This is 1,250 feet above the ground. And we're looking for this distance here. Complete our triangle. The important thing to know is that our angle of depression is actually right here. We don't have enough to solve for this angle, right? But what we notice is that this piece right here, this angle is a right angle, which means that this part plus that part equal 90 degrees. We can take 90 minus 37 and we get 53 here. Take a second to set up your equation and solve. Hit pause. Now that you've given it a shot, you can see that we're going to use tangent. We're going to say tangent of 53 equals x over 1250. We want to multiply both sides by 1250, getting 1250 tan 53 equals x, meaning that x is equal to 1,658.806 feet. These problems like this are super common. You'll see them in a lot of different fields. So we wanted to give you a good intro to them. In the next class, we are going to be working on a lab involving these type of problems. So be sure you review these if they're giving you trouble and email Miss Davis if you need any further help. That is all we have for today. So enjoy the rest of your day wherever you may be, and we will see you in our next video series.